My name is Edmundo. Today I'm going to talk about the symmetry of Fullerenes and related applications. This is a course of chemical structure bonding from Dr. Kenneth Hansen at Florida State University. Alright, so the Fullerenes are the most symmetric molecule that exists. They have 120 symmetry operations. C60, or Buckminster Fullerene, that was first discovered, has 32 faces. 20 of them are hexagonal rings and 12 of them are pentagonal rings. It is important to say that the carbon bonds in the hexagonal rings, they are shorter. They measure 1.38 angstroms, and the carbon bonds in the pentagonal rings measure 1.45 angstrom. They're a little bit larger than the other ones. And some of the symmetry elements in the Fullerenes are inversion point. They have 15 different mirror planes, 6 different C5 axes, 10 different C3 axes, and 15 different C2 axes. Some of those symmetry elements are shown in the figure. Here we can see the C2, C3, and C5 axes. This molecule is very symmetric and it has some consequences of that symmetry. The symmetry affects the chemical properties and reactivity of C60. If we imagine NMR spectrum, we can see that all the carbons are equivalent because we only see one peak at 142.68 ppm. Fullerenes C60, more specifically, has 2 subunities, 6 subunities, and each unity has 2 hexagonal rings and 2 pentagonal rings. It is important to say that the hexagonal rings are not aromatic. They're not because it is not a planar system, and the 120 degrees angle is distorted, so it's not aromatic. It makes those unities more reactive, and this is the reason why Fullerenes C60 are one of the most reactive allotropic forms of carbon, more than diamond, for example. And this tension explains the high reactivity. Another way to see it is the coronulins portion, and there is a barrier associated to that, and the value is about 10.2 kilocalories per mole at about negative 64 degrees Celsius. The Fullerenes have the tendency to be electron acceptors, and there is an application related to that that I'm going to talk about later on. And therefore their chemical properties are very similar to allenes, electrodeficient. In this slide, we can see a lot of reactions that the Fullerenes C60 actually do, and some of them are addition reactions with nucleophile agents. They do not react by electrophilic addition. They react by addition, radical addition, and cycloaddition 4+2. This is an application of the Fullerenes nowadays. As you can see, this is a solar cell, organic solar cell. There is an anode and a cathode. In this example, specifically, the anode is made of a layer of indium and tin oxide, and there is a PN heterojunction that is made from semiconductors, and there is also a cathode that is, in this case, is made from aluminum. And the application of the Fullerenes is that derivatives of such molecules are used as acceptor materials in such solar cells. So when someone irradiates with sunlight in this structure, there's going to be a photocurrent associated, and the derivatives of Fullerenes make it possible. Thank you very much. This is my presentation today.